All right, so let's continue our discussion on compound inequalities. We still have the same goal, but this time for this next problem, for this next example, we'll be working on a word problem. So to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive, okay? So your average should be somewhere between that. You scored 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? Okay, so first thing, we are talking about grade average here. Now, we know that when we're finding the average of your grade, you will have to add all the scores and then divide it by the total number of scores that you have. Okay, for this particular question, you are given 3 of the scores already, okay? So you will have 86 plus 85 plus 80. Those are the first 3. And we do not know the last 2, the 4th and the final test. So we can represent it as x, okay? So plus x also. Now, according here, the average needs to be between 84 and 86 inclusive, meaning you can include the value 86 and the value of 84. So we will have an inequality that will have an equal to included in there, okay? So this average, we still have to divide by 5. Because there are 5 scores. The average need to be in between 84, okay, and should be less than or equal to 86. So that's how our equation would look like. Now remember, when you are working with inequalities, compound inequalities, whatever you do in the middle, you also do on the 2 sides, all right? So here, we need to start with multiplying by 5 because everything that we need to do in the numerator needs to be divided by 5 as the last step. So we will start with the divided by 5. So everything needs to be multiplied by 5. Okay? All right. So let's see here. This is going to be 420, okay? 86 times 5, that's going to be 430. And so we will have something that is, so 86 plus 85 plus 80, that is going to be, so 8 plus 8 plus 8, that's 24, but there will be a carry 11. So that's going to be a 251 plus 2x. Okay, so what do we do here next? Now remember, our goal is to isolate our variable x, so we will subtract by 251 on the both sides, minus 251 minus 251. And so this will give us what? So this is now less than or equal to, this is now just 2x, less than or equal to, all right? So 420 minus 251, that's a 9, that's a 6, that's a 1, all right? This one is going to be a 9, a 12, and then a 3, so 179, okay? So now, to isolate our x, we need to, let me get that other color. We divide everything by 2. Oops, I lost it. There we go. So divide both sides by 2, okay? And so what will you get here? 169 divided by 2 is going to be, let me write it on this other side here. Sorry, my bad. So x needs to be, okay, 169 divided by 2 is going to be 84.5, all right? While 179 divided by, how do you call this? Divided by 2, that would be 88.5. All right. That's a 16, and then that's a 19. Oh, it's an 89.5. Sorry, my bad. Yep, sorry about that. It should be 89.5. My bad. Oops. Let's get that corrected. So that should be 89.5. So the test score that you can get for the last two tests, just to make sure that you will get an average, a B, between 84 to 86, your average is somewhere there. You should get 84.5 up to 89.5 for those last two tests. Okay? So let's work on compound inequality, but this time it is using the word or. All right. Now, unlike compound inequalities with and, you can have one. You can see that here in our example they are separated like this. Okay. Now, if you are going to have them as or, okay, you will notice that you can combine them in one expression, and I'm going to show that to you later on, okay? So in here, we can work on both of them, okay, individually. So why don't you try to solve for t on this inequality and also solve for t for this inequality. Try it out first. Go ahead. So if you work on the 3t plus 2 is less than negative 7, solving for t, you will have an inequality that will be t is less than negative 3, okay? Now, on the other inequality, negative 4t plus 5 is less than 1. Simplifying the whole thing, you will end up having to divide by negative 4. And so, as you can see, our inequality will switch directions. So if you are going to graph them, they will be pointing at different directions. So negative 3 less than, it's all to the left. Greater than positive 1 is everything onto the right. Okay? And so another example here. So why don't you work on solving for y, and then let's graph the inequality as well. Go ahead. All right, so if you will have negative 2y plus 7 is less than 1, you will end up having y is greater than 3 because you will be dividing by negative 2 on that computation. And then for 4y plus 3 is less than or equal to negative 5, you'll end up with a y is less than or equal to negative 2. And so the graph would look like this. So here's the tip that I was mentioning to you earlier, okay? You will notice that if your compound inequality, and I'm gonna have it here, okay? If you will notice from our previous examples earlier, when we had the word and, you will notice that the expression, I'll just put exp over here, okay? You will have a less than or equal to as your compound inequality, okay? So for example, negative 3 less than or equal to x less than 5, something like that. If you graph that, they will connect, okay? Now, here's the nice thing. We, as in our two examples here, we don't see a compound inequality with or in just one complete inequality like this. Why? Because here's the thing, all right? You gotta remember this. For or, okay, your inequality, whatever expression that is, uses the greater thans. Okay, so for example, if you're going to take a look here, okay, this one over here. So we have a y is greater than positive 3. Yes. Now, if you're going to take a look with this part here, with this one, if we are going to rewrite it so that the y is this y over here, and this is negative 2 over here, you will see that negative 2 has the opened part, all right? And so you will see that if you have the greater thans in that compound inequality, that's when you have an or. And so your graph will be pointing to different sides, okay? That's just one tip. You don't have to memorize it. I'm just sharing that out just so you don't panic if you see, oh, why is this all greater than now instead? And then you will have a graph that is pointing both to different sides, okay? So do not associate a compound inequality just like in one expression like this to be always connecting in between, okay? If they are less than, that's when they will be connecting. If they are both greater than, then they will be on opposite sides.